We talked about this last unit. If we have the same base to a power, then the exponents have to equal each other, all right? So we're going to really be focusing on using this idea for all of these problems here. What you are going to want to try to do, you're going to want to rewrite so it has the same base, and then set the exponents equal to each other and solve. So this is a little bit review, but we're going to go a little more in depth with the number values and some of the solving. So here we have 5 raised to the 2x equals 5 to the 16th. So what is the equation we can set up? 2x equals 16. Therefore, what does x equal? Done. Easy peasy. Okay. How about this 27 right here? How can we change that? So our first step, we're going to try to rewrite it so they have the same base. So if the base here is 3, we're going to rewrite this as 3 to the what power? 3 to what power is 27? All right, and then now what is the equation we can set up? You bet. And therefore, what does x equal? You got it. Nice job. Okay, now this one's a little harder, so let's go over a little bit of exponent properties. If you have a fraction raised to an exponent, that means this is the same as like 5 to the x over 6 to the x. Like you would raise both the numerator and the denominator to that. Now with that idea, let's see if we can rewrite this fraction as 5 over 6. So instead of 125, we would have what? 5 to the third, and 216 is going to be 6 to the third. That means this is 5 over 6. All of this, because the numerator and the denominator are raised to the third power, then this whole fraction is raised to the third power. And now we have the same base. All right, therefore, what is x equal to? Okay. This guy's a little bit bigger, but we want to go ahead and rewrite that. So we have 6 to the x squared power, and then 1,296 is 6 to what power? To the fourth. All right, so we have 6 to the fourth to the x, but anytime you have a power raised to a power, what do we do with the exponents here? Yeah, we multiply them. So we have really 6 to the x squared equals 6 to the 4x, which means x squared equals 4x. Now, what kind of equation is this? What do we call this because of the exponents, specifically in this problem? We have x squared. Anytime you see x squared, you should be thinking, right, set it equal to 0, because what kind of equation is this? Quadratic. Good. So we have x squared minus 4x equals 0. Okay, set it equal to 0, and then you want to what would we do here? What do they have in common? X. Good. So factor the x out, and then you get x minus 4 equals 0. Therefore, x equals 0, and x equals 4. All right, now E is a little bit harder because we have 256 and we have 64. Neither of those, like 64 is not a base of 256. But the nice thing about this is we can choose a base that they both have in common, right? So if we have 64 and 256, what would be a base that we would try to have in common? Like 64, for example, can be written as 8 squared, right? The problem is 256 is not 8 cubed. So 8 is not a good choice for a base. So let's find another base. So for 64, what else could we have for a base? 2, 4. We can try 4. All right, so for 64, that's 4 to the third power. And then 256 is 4 to the fourth power, okay? Turns out 2 would also work, okay? But 4, we can use that. So you can actually pick any base that they both have in common. I'm going to use 4 so our numbers are a little bit smaller, but if you use 2, when all is said and done and you solve for x, you're going to end up with the same answer, okay? So we have then 256 is 4 to the fourth, and that's raised to the 3x. So this is my 256 raised to 3x. 64 is 4 cubed to the x plus 1. Okay. Now we had mentioned if we have a power 2 power, so we have two exponents here, we're going to multiply those. What is 4 times 3x? 12x. What is 3 times x plus 1? 3x plus 3. So you do need to be careful when you have a binomial for an exponent. You need to distribute. Okay, so here we're going to end up with 3x plus 3. What are we going to do to solve? So we get 9x equals 3. Therefore, x is? What's 3/9 so?
X equals 3.
Anybody reduce? Did someone say it? You might have said it. I didn't. 1/3. Okay. For f, what is the base we're going to want to use for both of them? 3. So this one already has 3 for the base. How do we change the 9? 9 is 3 squared to the 5x. On the left-hand side now we have x squared minus 56. What are we left with on the right-hand side here? 10x. What are we going to need to do to solve? What do we do to solve this problem?
You get the 10x on the left side.
Yep, set it equal to 0, so subtract the 10x. Good. So we have x squared minus 10x minus 56 equals 0. Now what? Yeah, 56. What is that? What two numbers multiply to 56 and add a negative 10? Ooh. 4 and 14. Right? So what are we going to get for 4 and 14? Which one's which? Negative 14, because we have a negative 10 and a positive 4. So then x equals negative 4 and x equals positive 14. Okay? Now for this last one here, if we have 11 to the x power equals 5, we want to know what 11 to the negative 2x is. All right? So the way this is going to look then, let's start with what we have. We have 11 to the x equals 5, okay? Now, what am I doing to this to get 11 to the negative 2x? How can I change this to get this guy here? What would I have to raise this to? Negative 2. But if I raise the left-hand side to the negative 2 power, then to keep the equal sign,
Right-hand side.
yes. So what is 5 to the negative 2 power? What does the negative do? The negative makes it the reciprocal. So 5 squared is 25, but the negative part will make it the reciprocal. So we have 1 over 25. So we're looking for the answer to what does 11 to the negative 2x. We're not trying to solve for x here. We're trying to figure out what is this equivalent to, and it's equivalent to 1 over 25.